Hey guys, so this is going to be the last section in chapter 4. It's going to be the last graphing section that we're going to do. Now, obviously we've done sine and cosine, so we still have tangent, cotangent, cosecant, secant to do. Now, what I'm going to mostly just focus on here is what tangent looks like, because I think that's out of those 4, that's the most important one to know. And I'll show you what the other 3 look like, but I'm not, your homework is mostly just going to be tangent graphs. But I'll just show you what the others look like, just so you have an idea. But first part will just be tangent, and then I'll show you what the other ones look like. Okay, so you're doing tangent of x, right? Now remember, tangent is y over the x term, okay? So if you have your unit circle out, coming up with the values is going to be pretty easy. Okay, so what I'm going to do is I'm going to do pi over 4, pi over 2, negative pi over 4, negative pi over 2. And once we come up with those values, that'll make sense in a minute. Okay, so for the first one, right, at 0, right, tangent of 0. So the point at 0 is 1, 0, right? So if I do 0 over 1, I'm going to get 0. So my first point here is going to be 0. Okay, now at pi over 4, I get root 2 over 2, root 2 over 2. Now, if I do the y term over the x term, I'm just going to get 1. Okay, so I'm going to put a point there at 1. And then if I do pi over 2 is 0, 1. Okay, so if I do y over x, right, I get does not exist, right? So anywhere, again, you have a point that doesn't exist, you need an asymptote there. All right. So tangent is going to be undefined at pi over 2. Okay. Now negative pi over 4 is the same thing as 7 pi over 4. Okay. So that's going to be y over x. You're going to get negative 1. Okay, because the y term is negative in that quadrant. And then at pi over 2, negative pi over 2, it's also going to be undefined, because it's going to be negative 1 over 0. All right. So what the tangent graph looks very similar to is like our x cubed graph. So it has that kind of similar wave. So you're going to start like at the bottom and then kind of come up and then finish up at the top there. All right. Now, this is one cycle of what the graph looks like. All right. Now, if you notice the distance from between the two asymptotes, negative pi over 2 to pi over 2, is 1 pi. So that actually is your period. So the period is now pi. So the same way that we figured out period from doing sine and cosine, it's going to be the same for doing tangent, except instead of using 2 pi, we're going to use 1 pi. Okay. Now it doesn't have an amplitude because it goes towards negative infinity and infinity. Okay. Now the biggest things that you guys are going to focus on is really, this middle point right here that I did at 0, 0, and then where your asymptotes go. Okay. And then if you have, if you want to do the other points, you're more than welcome to. Okay, so if I wanted to do the next cycle for tangent, right, my period is pi. So I'm going to take this middle point here, and I'm going to put it 1 period away, which 0 plus pi is going to be pi. Okay, so that would be my next point. All right, now if I wanted to figure out where's my next asymptote going to be, I'm going to add 1 pi to pi over 2, which is going to be 3 pi over 2. Okay. Now your cycle is going to look the same. It's just going to start at the bottom and then go through where your across the axis, and then go up. All right, and then that keeps repeating. Goes in both directions. All right, so if I wanted to go to the left now, right, that would be negative pi. That's 1 period away. That's going to put my first point. Okay, and then my next asymptote, right, is going to be negative 3 pi over 2. Because again, that's 1 pi away from negative pi over 2. All right, and then again, you start at the bottom and you finish up at the top. Okay? So again, the biggest thing for tangent is the period, right? So again, the distance between the points is the period, or pi, and then also the distance between the asymptotes is also the period, which is pi. Okay? So your domain is going to be x cannot be pi over 2 plus pi n. Okay, so every unit of pi after that. And then your range is just all real numbers. Okay, so let's go down to number 3 here. So for the first one, 2 tan of x plus 1. Okay, so what I'm going to do is I'm actually going to change this just to change it up a little bit. So I'm going to make this y equals 2 tan of 2x plus 1. Okay. Now, like I said, the biggest thing you need to figure out is where's your period, right? So my period now is going to be pi instead of 2 pi. The period is always pi. Pi over the b term, which is this 2 here. Okay? So every pi over 2, I'm going to put a point. All right? So I'm going to do a couple cycles here. Okay, so normally my point starts at 0, 0, okay? But now I'm moving that up 1, okay? So I have a point here at 0, 1, okay? Now my next point is going to be 1 period away, so that's pi over 2. So pi over 2 and 1, all right? Now if I go in the other direction, that's negative pi over 2. Okay, now I'm not really paying attention to this 2, even though it's out front, because again, tangent goes up to negative infinity, infinity. So it doesn't really affect my values, okay? Now, where do you put your asymptotes? Now, your asymptotes are going to be in the middle of those 2 points, all right? So that's pi over 4, okay? So put an asymptote there. And then 1 period away from pi over 4 is going to be 3 pi over 4. So I'll put that like here. Okay, then we got negative pi over 4. And then negative 3 pi over 2. 3 pi over 4, sorry. All right, and then you're just going to draw your curve like it did the last one, except now it's going to change the concavity right there at y equals 1 instead of y equals 0. Okay. So again, just changing the equation up a little bit just to get different values. So again, the biggest thing, you always start with the point at 0, 0, move that around, and then the other points are just 1 period away. Okay, and then for dropping down to the third one, okay, so we have y equals tangent of 2 parentheses x minus pi over 4. All right, so pi over 2 divided by 2 gives you pi over 4. Okay, so my period, again, is going to be pi over 2, right? Now, we're also going to be moving this graph right pi over 4. All right, so that's going to change where I start my curve. Okay. Now, instead of starting at x equals 0, I have to start at pi over 4 because I'm moving my entire graph right pi over 4. So I have pi over 4 now is going to be my first point. Okay. So 1 period away from that, right, is going to be 3 pi over 4. All right, and then 1 period away in the other direction is going to be negative pi over 4. Okay. Now you just need to figure out where your asymptotes go. So in the middle of pi over 4 and 3 pi over 4 is pi over 2. Okay. Now add 1 period to where your asymptote is. So pi over 2 plus pi over 2 is pi. Actually, I should make that a little bit closer. Okay, and if you take away 1 period from pi over 2, you get 0. And then negative pi over 2. Okay. So if you guys notice, like if you look at the distance between all of your, like the points that I did in blue, the distance between them is 1 period, or pi over 2. If you look at the distance between all the asymptotes, that's also 1 period of pi over 2, okay? So the biggest thing you really need to look for when doing tangent is just figuring out what the period is. Okay, so that's pretty much how you draw tangent, right? And then I'll just do a quick graph of the other 3, okay? So for the first one, cotangent looks very similar to tangent, okay? So you draw your axis. Now, when we did tangent, we started at x equals 0, right? And when that was a point, okay? But if I do the coordinate at 0, and now cotangent is x over y, right? If I do 1 over 0, I get does not exist, right? So instead of a point being at 0, I'm going to have an asymptote, okay? And the same way that the period for tangent was 1 pi, that's also for cotangent as well. So 1 pi away is going to be another asymptote. And then in the other direction as well. Okay, so now what would be in the middle of that, right? So if you do pi over 4, right, cotangent of pi over 4, that's 1, okay? Cotangent of pi over 2 is 0, and then cotangent of 3 pi over 4 is negative 1, okay? So what that should look like, I got pi over 4, that's 1, pi over 2 is 0, and then 3 pi over 4 is negative 1, okay? So it'll look very similar to tangent, it's just flipped. But you still have your asymptotes, and you still kind of have the same shape. It's just flipped. Now, one period away from pi over 2 is negative pi over 2. So that's where your other points would go. Okay, so if you have to do the tangent graph, you start with the values and do the asymptotes second. I think when you're doing cotangent, you do the asymptotes first, and then you do the points second. Okay, but the period is the biggest thing. Always starts with 1 pi. So that's how you do cotangent. And then cosecant and secant. Now cosecant is the opposite of sine. So it's the opposite of sine of x, right? So what we're going to do is we're just going to draw sine of x first. And you'll see how easy it is once you have that. So I'm going to go from negative 2 pi to 2 pi, okay? So we're going to go up to 1, negative 1. Now I'm going to very lightly draw the sine graph, okay? So so you have axis, high, axis, low, axis, right? Okay, so that's sine of x is here in orange. So axis, high, axis, low. Okay, so we have sine of x, right? Now cosecant of x is just the opposite of sine of x, right? It's the reciprocal of sine of x, right? So if my value for sine of x, say here at 0, right? The reciprocal of 0 is 1 over 0, which doesn't exist, right? So anywhere you see you have a value of 0, you're going to draw an asymptote because 1 over 0 is undefined. Anywhere I see a value of 0 becomes an asymptote for cosecant. Okay, and then to draw the graph now, right? If you see this high point here at pi over 2, what cosecant does is that it starts up at the top. I don't want it to do that. It's going to come down, go to that, and then come back up. So it falls in between where the asymptotes are. All right, and then the other side comes up to where negative 1 is and then comes back down. All right, so that's one cycle there of cosecant. So you got your low point and then your high point. Okay, so it's pretty crazy looking, right? But again, it's not hard to draw. As long as you know what sine looks like, you can do the graph for cosecant. So this here, that's one cycle for cosecant. And very nicely enough, secant is, you work it out just the same. Okay, but secant is the opposite of cosine, right? So we're going to do the same thing. So pi over 2, pi, 3 pi over 2, 2 pi. Going to go up to 1, negative 1. All right, so again, I'm just going to draw cosine. So high axis, low axis, high. So you have your basic cosine curve, okay? And then again, anywhere you see cosine is 0, that means that secant is going to be 1 over 0, or undefined. So asymptote at pi over 2, and 3 pi over 2, negative pi over 2, 3 pi over 2. Okay, and then high points, your curve is above, and then low points are below. All right. Now, obviously I would keep going for this. I just don't have the points labeled, but That's how you do secant. All right. So they're pretty easy. As long as you know what cosine and sine look like, it's pretty easy from there. All right, guys. So if you have questions, let me know. Thanks.